Welcome to the Geoscientist. In today's tutorial I'm going to show you how to estimate your stresses. So we have like three stresses in our subsurface. We call them the horizontal stresses. One is the vertical stress, which we already estimated in our previous tutorial. You can go to my playlist, the name of TechLog tutorials. You will find there a tutorial on the estimation of pore pressure and overburden stress calculation. So we have already estimated our vertical stress there. Now we are going to estimate our the horizontal stresses, which is minimum horizontal stress and the maximum horizontal stress. So let's jump into it, or before going to that, if you haven't subscribed to our channel yet, please do subscribe to Geoscientist and share it with your fellow geoscientists. I hope they will get benefit from it as well, and do comment if you like our video or not. So let's start. So here we have our main button. So from here, go to this under the geomechanics, select geomechanics. Under geomechanics you have this horizontal stress. Select this one, and from drop down menu just go, you have different models to estimate the stress gradients: Mohr-Coulomb stress boundary model, poroelastic horizontal strain model, horizontal stress from the effective stress ratio. I'm just going to go with this poroelastic horizontal strain model. Most of the time I'm using this model, so select this one. So it will ask you Poisson different variable input variables, one of which is Poisson ratio static, Young modulus static, Biot coefficient, vertical stress, pore pressure, epsilon SHmin, epsilon SHmax. So the values which are in the white, they are the must required values. You cannot compute stresses without these values. The grayed out values, they are not required here. You can provide these values in the upcoming tab as well. So I'm going to I have most of these values except for epsilon SHmin and epsilon SHmax. In the previous tutorial I showed you how to estimate your elastic properties and rock strength properties along with the Biot coefficient. So I already have estimated the pore pressure in one of the previous tutorials. So I'm going to provide these two values, Biot coefficient and pore pressure here, and the others are already selected. If they are not selected, you can just drag and drop these things over there. So first of all, with the Biot coefficient, here's my Biot coefficient. I'll just drop it here, and my pore pressure, going to provide my pore pressure here. I don't have epsilon SHmin and epsilon SHmax, so these are the two constants. They depend upon your lateral heterogeneity or lateral variation in the stresses, local stresses or the regional stresses. So sometimes you need a complete model of your area, geological model, a structural model of the area to define these two variables or the constants. So if you go to the estimation equation of SHmin and SHmax, that considers the heterogeneity in the maximum horizontal stress direction and the minimum horizontal stress direction. So it estimates that we provide that epsilon over there, but right now we are going to provide this constant depending upon our actual data we have recorded in the well. So we will somehow back calculate these parameters. So hit create and drop your logs dataset from over here. So it has selected all your values. So in the vertical stress, it has selected the effective stress. You do not need this effective, you need this vertical stress. So change it to vertical, and in the zonation tab, if you want to select the zones in parameters tab, so there are these two parameters, epsilon SHmin and epsilon SHmax. So the area where I am working, So I am going to just use 0.0001 for SHmin and 0.0005. I'm working in the compressional regime, so I know these epsilon SHmin and SHmax for my area. One thing important to note, to calibrate your stresses, you need to have certain data which will calibrate your stress data. First of all, the most important is the SHmin. Your acquired data which is calibrated with the SHmin is your FIT data, formation integrity test, which you do during your drilling, your LOT data, leak off test, and XLOT, extended leak off test. Or if there are losses in your well in certain formation, that is also a calibration point for your SHmin. So if you look at the curves of LOT and XLOT, so when you start pumping the pressure or the mud into the formation, first of all your fracture initiates. That is the pressure where the fracture start to create. That is your fracture initiation pressure. If you have FIPG, you can use that one. And once the fracture is initiated, the pressure start dropping. At certain point, it gets stable, and that is the fracture closure pressure. Your fracture closure pressure is basically your SHmin. So if you have the extended leak off test XLOT, so your fracture closure pressure is your SHmin. So that's why you should have to have your these sort of drilling event data with you to calibrate your estimated value. So we have calculated 0.0004 from our fracture closure pressure, so we know this is our SHmin. So you give your SHmax value over here or not, just here give this value, but we are going to estimate SHmax with a different method. I'll show you in the next step. Just hit compute button. So here you have your both of these values. So let's see what it shows me. So my blue curve is pore pressure, the green curve is my SHmin, and red curve is SHmax, and my this curve is vertical stress. So this is how you estimate your minimum horizontal stress. You can just calibrate your minimum horizontal stress with your data. Right now there seems some issue with my data or importing, or because this is just a workflow, so I haven't calibrated some of the data because I am working in the compressional regime. My maximum horizontal stress should be way beyond this vertical stress. In the compressional regime, your maximum principal stress is the SHmax, which is the maximum horizontal stress, then SHmin, which is the minimum horizontal stress section, and the least stress is the vertical stress. So but here my vertical stress is the higher side, which shows that I am working in some sort of normal stress regime, but it's not the case. Anyhow, I hope you understand the workflow. So you can just play with these parameters here, like if I change it to 0.004 and I use this to 0.005 and hit play again. So now see, my stress values are going beyond my vertical stress. So you can play with these parameters, but you have to calibrate. Suppose I have my sort of FIPG or a fracture closure pressure at this point, so my stress should be calibrating that with that estimated stress, minimum stress should be calibrated with that one over here. So if I go to SHmin, I use it to 0.0001. Let's see how it comes out. So this looks a bit okay with the area I am working. I'm not going to use SHmax estimated here, because I'm going to estimate it with a different method. I'm going to use it to before. Let's see. And yeah, I'm going to save this my SHmin, save variable. Okay, and close this tab for now. Want to save the workflow layout? No. Now I'm going to this horizontal stress tab again and going to estimate maximum horizontal stress as a function of minimum horizontal stress. So it's a very simple formula. You just multiply your minimum horizontal stress with a tectonic factor. Tectonic factor is defined region wise, so you can use the tectonic factor and multiply your minimum horizontal stress with that, and that will estimate your maximum horizontal stress. So I'm going to hit create. So it is getting the value SHmin PHS, which I just estimated in zonation tab. You can import the zonations from the zonation window, global zonation window, which I have demonstrated in the earlier tutorials as well. And in parameters tab, what sort of the multiplier you are going to use here. This is called a tectonic factor. So in my area it is around 1.35 to 1.45. I'm going to use it as 1.41, and I just play button. So here is my maximum horizontal stress. So I'm going to just move them in the same track. I'll just move it in the same track. So I will also drop my vertical stress over here to see how my stress regime looks like. So here it is. So at some places, like for example over here, it seems like a strike slip component from top till this place over here. It is all reverse regime. Here it shows sort of a strike slip because vertical stress is in between horizontal and minimum horizontal stress. Here again the reverse regime. Here somehow again the strike slip movement, and it's sort of a mix sort of a stress regime. It seems like a transpressional regime with a extension with a compression and compression and strike slip movement. So that's how you calculate your minimum and maximum horizontal stress. I'm going to save this variable because later on I'm going to use this for my wellbore stability analysis. So this is how you estimate your stresses. So use the method whichever you feel is good for you. For the theoretical part, I'll recommend you guys to go and attend the lecture from Mark Zoback, the Stanford professor. His lectures are available on the YouTube and some other free courseware website like Coursera. You can go to Coursera and find this reservoir geomechanics course for Mark Zoback. You will benefit a lot from that course. You will get the understanding of the basic geomechanics concepts. So basic reservoir geomechanics concepts, first of all you have to build your theory, and then you can come over here and estimate all the curves with that good understanding of the reservoir geomechanics, because software is nothing, is just what inputs do you use, it will give your outputs. A good example for that is a garbage input gives a garbage output. So first of all, you have a good understanding of your geomechanics concept. Once they are built, so it will be very easy for you to do the geomechanics on the software. The workflow is quite easy. It's not a rocket science, but you have to have very good concepts, which parameters to use, what is the QC for the parameters, how to calibrate your parameters with your actual values. So anyhow, that's it for today. I hope you understood all the workflow for the stress calculation till now. In the next tutorial, I'm going to tell you how you can do your complete wellbore stability analysis, and that will help you out during the pre-drill planning of the well and the post-drill post-mortem of the well as well. So if you like the video, do subscribe to our channel and share it with the fellow geoscientists, and hit the like button. See you in the next video. Bye bye.